Our client was Scientific Aviation, an airborne research company based at the Boulder Municipal Airport. Their problem for us was simple. When transporting planes from the runway to the hangar, they used a simple tow bar. This bar worked for the majority of situations, but a lip or incline near the hangar could cause a lot of trouble for one person. They needed us to design a tug that could handle these inclines using only one person, and still be lightweight and compact enough to fit in their small plane. Our goal was to physically build the tug, but obviously the virus has affected everybody's plans, so we decided to make a virtual model of the tug as well as IKEA instructions on how to assemble it if it were to be built.
Our main design goal was to keep the simplicity of the manual plane tug, but to improve the user's ability to move the plane by themselves. To achieve this, we added a lever to our plane tug. This lever has the versatility to move its axis of rotation to 2 different points along its length, and it also allows for the user to provide impulses to be able to get the plane over lips on the ground and up short inclines. Another design constraint we worked around was space, which we accounted for with the lever's ability to fold up into a storage position. We knew that the lever and the pin it was rotating around would both be subjected to large loads from the user and the plane, so we ensured that the lever would be able to withstand both lateral and axial loads by providing the support members shown right now and making the walls of the lever the appropriate thickness. Lastly, we included a foot pedal on the bottom of the lever so that the user would have more ease of use during moving it, and that would ensure the lever's functionality even in adverse weather conditions such as ice or snow.
The tug works by first putting the lever in the position shown when encountering an incline and pulling the handles towards your chest while pushing the foot pedal into the ground with your body weight. Then, when the lever returns to this position with the natural motion of the pull, you can continue pulling the plane while utilizing the impulse just given. Our design process primarily focused on getting to as many prototypes as possible. Once we brainstormed our idea, we began building cheap prototypes to visualize our idea. Shown is our first wood prototype, and we moved on to a PVC prototype immediately before the virus quarantine started. We finally decided to build our final design out of aluminum, so we carried out various stress calculations to determine the correct size and type of aluminum, as Reed will now explain further.
Here are the stress calculations. We made some basic assumptions. We put the plane at 3,200 pounds. We're setting the angle of the ramp to 3 degrees, and we're using the coefficient of static rolling friction at 0.03. So here are the free body diagrams. The one on the left is the one for the plane. We have the weight going down in the X direction down the ramp, and we added that to the force of friction to come up with the force that we need to get the plane moving up the ramp. And we put that force as a third law pair on the lever right in the middle, because that is where the max bending moment is going to be the highest. So we made some calculations here. We have the cross area of the tubing that we're using, and we calculated the max stress to be just under 13,000 psi, but we found that was not sufficient because we have to account for this 0.5-inch hole that we're putting right in the middle of the tubing. So we're using an in-plane bending formula to come up with the max stress for each wall on the side of the tubing. We're dividing that between 2 walls, and with those calculations we came up with about 24,000 psi. We threw a safety factor of 1.5 on that, and we came up with 36,000 psi, and for that reason we chose 6061 T6 aluminum as our material, which has a yield strength of 40,000 psi.
In the future, we would like to work on making the tug more portable, possibly with a telescoping mechanism, and with a more seamless design by reducing the time needed to set up the pins and lever. Overall, the aesthetics could be improved as well with a smoother finish and the addition of the Scientific Aviation logo. Obviously, group projects can be difficult, even more so with the global pandemic, but our team worked well together and was able to grow from a group of 4 guys who knew nothing about airplane tugs to the group today, proudly showing you this video of our semester-long project, on which we worked extremely hard. Thank you.